All right, here we go. So we went over. So we went over 33, which looks like that, and 47, which looks like that. So if you're gone, you can pause the video to see what they look like. But today we're moving on to tangent. So we're doing section 2.4, tangent and cotangent. All right, so what will the tangent and cotangent curves look like? Well, if we're at 0, if we're at pi over 4, if we're at pi over 2, if we're at 3 pi over 4, 3 pi, or pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Let's do tangent first. All right, so looking at your unit circle, what's the sine of 0? 0. What's cosine of 0? 1. What's 0 over 1? What's 0 over 1? 0. Pi over 4. The sine is square root 2 over 2. Cosine is square root 2 over 2. What's square root 2 over 2 over square root 2 over 2? 1. Because 5 over 5 is 1. 12 over 12 is 1. So square root 2 over 2 over square root 2 over 2 is 1. Pi over 2. What's the sine of pi over 2? 1. What's the cosine of pi over 2? 0. What's 1 divided by 0? Undefined. What do we put at an undefined, do you think? An asymptote. We'll put an asymptote there. 3 pi over 4. What's the sine of 3 pi over 4? What's the cosine of 3 pi over 4? So we have a positive divided by negative is a negative 1. Pi. The sine is 0. Cosine is negative 1. 0 over negative 1 is 0. 5 pi over 4. It's a negative divided by negative, which is a positive 1. 3 pi over 4, or 3 pi over 2, I mean, is undefined. 7 pi over 4. Signs are opposite, so it's negative 1. 2 pi is the same as 0, which is 0. So what will it look like? So there's pi over 2, pi, 3 pi over 2, 2 pi, and if we need to, we'll go over to 5 pi over 2. All right. So what I want to do right now is put in my asymptotes. I have asymptotes at pi over 2 and 3 pi over 2. Okay, and I'd have another one over here at 5 pi over 2. Okay. So if this is, whoa, didn't mean to go there. This is 1 and 2, negative 1, negative 2. Okay. At 0, we're at 0. At pi over 4, we're at 1. 3 pi over 4, we're at negative 1. Then we have 0. Then we have 1. Negative 1, 0, 1. Okay. So what will the graph look like? Well, since this goes down like this, we're kind of an asymptote we're running along this asymptote. We slide this way. Then once we get close, we slide up on this way. So it looks like that. No matter where I am on the tangent curve, my slope is always what? Positive or negative? Positive, because it goes up from left to right. So when you do tangent, I want at least two curves. I want at least two curves done. Okay? Two tangent curves. That's what tangent looks like. We good with that? Okay. Cotangent of x. Okay, cotangent. So that's cosine over sine. Add 0. Cosine is 1, sine 0. What's 1 divided by 0? Undefined. Pi over 4. 1. Pi over 2. Because it's 1 over 0, which is 0. 3 pi over 4. Negative 1. Pi. Undefined. 5 pi over 4. 1. And then 0. And then negative 1. And then undefined. See how it follows a pattern there? Undefined, 1, 0, negative 1. Undefined, 1, 0, negative 1. Tangent's very similar. Okay, where are our asymptotes at? 0. We have a good old asymptote right there. At pi. And then at 2 pi. All right, so at pi over 2, I'm at 0. At pi over 4, I'm at 1. At 3 pi over 4, I'm at negative 1. Now what's the slope going to be for cotangent? Negative. Cotangent is always a negative slope. Unless you're multiplying it by a negative 1. Or negative 2 or negative whatever out front. Then I'll change it. But I'm not going to do that to you. Okay, I'm not going to have you multiply by a negative. All right, so what do we do with cotangents besides graphing tangent and cotangent? Well, we'll change a period on you, okay, and do things like that. Such as, I'm going to make this small now so we can figure this out. The cotangent of 2x. So I need to find the cotangent of 2x. Well, what happens there? The 2 for period makes it twice as wide or twice as skinny? Twice as skinny. So what you have to do is you do not have to graph the original cotangent curve. When we're dealing with tangent and cotangent, just the final answer is good. All I need is the final answer. Okay? So if you're told to graph the cotangent of 2x, you make your graph. And I go 4 to get to pi over 2. 4 more to get to pi. 4 more to get to 3 pi over 2. 4 more to get to 2 pi. 1, 2, -1, -2. Okay, so the cotangent of 2x is twice as skinny. So I still have an asymptote at 0, because 0 doesn't change. But twice as skinny, if I had an asymptote at pi, now where would the asymptote be at? Twice as skinny. Pi over 2. Then where would the next one be? Instead of at 2 pi, it'd be at pi. Twice as skinny. Okay? So cotangent. Look at how cotangent is. Halfway in between 0 and pi, it's right on the x-axis, right? So we would be right on the x-axis, halfway in between my asymptotes. And the slope is negative. So I'd have a point right here. Sorry, bad computer. And a point right here. So halfway in between, since we have a negative slope, I have a point right here and a point right here. 1 away this time instead of 2 away because it's twice as skinny. So everything's twice as skinny, twice as close together. And that's what the cotangent of 2x would look like. Capiche? Okay. So that's changing the period. I'm not going to have you change the period where we're factoring out something crazy. I'm just having you change the period, call it good. And then the only craziness we'll do is I'm going to go up here and do it so you can see the tangent curve. You'll want to be able to see the tangent curve and the cotangent curve to do your final answers. Is the shift left and right get a little bit funny, but it's all right. You should be able to handle it. But let's say we had y equals the tangent of x minus pi over 4. The tangent of x minus pi over 4. Now, I'm after just the final answer here, right? So if I'm after just the final answer, I'm going to make my shift right off the bat with these. So pi over 2, pi, 3 pi over 2, 2 pi. Okay, so my asymptote was at pi over 2. If I go minus pi over 4, what happens? Goes to the right how far? 2 squares to the right. It was at 3 pi over 2, so I go 2 squares to the right. How far is it in between my asymptotes? How many squares? 8. So I go another 8 squares. 2, 4, 6, 8. Who do you appreciate? Not Mr. Bierschbach when he assigns a whole bunch of homework. That's for sure. Okay. So then, the tangent curve has a positive or negative slope? Positive. So, the tangent curve had a point at -1 and then 0 and then 1. So halfway in between these asymptotes, I better be at a 0. And then I went 2 to the left and 2 down. And since I'm not changing my period, everything's the same. So 2 to the left, 2 down from that point, 2 to the left, 2 up. There's my positive slope. So halfway in between, to the right and up, to the left and down. How does that look? Does that look very difficult? No? Okay? All right. So, what I'm going to do is I'm going to assign 4 problems, and that's it. We're not going to have a second lesson today or anything like that. 4 problems, and that's it. Page 144. Okay? The problems will be numbers 26. And you have to graph this. It says determine the period of the function. No, I want you to graph this. So 26, we're graphing. 40, we're graphing. 43, we're graphing. And then 45, it's what it is the cotangent. Oops. The cotangent of 1/2 x. Because it says x over 2. A lot of you wouldn't figure out that that means 1/2 x. So that affects your what? Period. So it's going to be half as wide, or not half of wide, but it's going to be 2 pi divided by 1/2, which really means it's 2 pi times 2. So instead of be twice as skinny, it's going to be twice as wide. So yeah, that one you have to make wider due to the period. So figure that out. Figure that out if you can. So there you go. That is your assignment. Only one assignment today. You should get it done during class. If you have questions, you can surely ask.